Hello all, welcome to this new lecture in computer graphics. In this video lecture, we are going to cover how to draw a circle using the midpoint algorithm. In this lecture, we are going to cover the derivation of the algorithm. We are also going to understand how the circle works. And finally, we are going to see the example and the working through the example how to derive a circle, right? So how to bring about the points through that algorithm. So let's get started. Now, as we all know that a circle is a symmetric figure. So we can see that a circle is a set of points that lie at an equal distance from the center. So if I say that this is the center, then all the points, they lie at an equal distance from the center. And what is that distance? That distance is nothing but the radius, right? Now, a circle is actually a symmetric figure, okay, and we can say that we can use eight-way symmetry in a circle, which can give rise to eight octants, which are symmetric to each other. So you can see octant 1 and octant 2 is symmetric, right? Similarly, octant 2 and octant 3 is symmetric, octant 3 and octant 4 is symmetric, and so on. Okay, so if we want to plot a particular circle, what if we just derive the points on the circumference only for the first octant? That would be enough, right? Because if we get this particular points, we can replicate those using the mirroring property or the symmetric property of the circle. And similarly, we can get the points for the other octants as well. Like if I get the data points for octant 1, I can just replicate them for octant 2. So similar, in that case, I'll be getting it for one quadrant completely. If I get it for this quadrant, okay, I just need to mirror it with respect to x-axis, right? And when I do that, okay, I can directly get the values for octant 3 and octant 4, right? So using the first quadrant, I can get it for the below right quadrant, right? So what is the changes that will happen in a point? So you can see as octant 1 and octant 2 is symmetric to each other, if a point is represented as BA over here, right, which is B is the x-axis and A is the y-axis. So in that octant 2, okay, that same point will be represented as AB. So it'll get interchanged wherein A will be representing the x-axis and B will be representing the y-axis. Similarly, you can see that if I'm going from octant 2 to octant 3, then nothing changes but only the sign of the y-axis. That's why the B is represented as minus B in octant 3. Similarly, you can see for octant 4, the BA which was there in octant 1, okay, that is just replicate or mirrored in octant 4, wherein we just change the sign of the y-axis. Similarly, we can see that if we get the entire half of the hemisphere here, okay, or the semicircle, we can just replicate it on the other side, and similarly we can get that point. So we can see in this case, this particular point BA is mirrored on the negative y-axis, right? And only the y-axis sign gets changed from B to minus B. Similarly, you will see over here that again AB is replicated and you get minus A comma B, right? Similarly, you see that A comma minus B, again you get only a minus sign for the x-axis, that is minus A comma minus B. Similarly, for B comma minus A, it is minus B comma minus A. So this is how we can get the points for all of the axes, right? All of the quadrants, and then we can make a circle. Now, but we could have done it the other way around as well, right? How we could have done it is that we have the equation of the circle, which is x squared plus y squared equal to r squared. This is the equation of the circle when your origin of the circle, okay, is at the origin of the coordinate system, right? That means the center of the circle is lying where? At point 0, comma 0 onto the coordinate system. Now, if we do that, we can actually use the brute force method to get the value of y, right? We can keep the value of y at one side and we can do under root of r square minus x square, and we know from where to where the x is going to range. X is going to range from 0 to positive r, and again from 0 to negative r, right? That is your radius. So if we keep on placing those values, we'll be getting the points for the y-axis, and that's how we can plot the entire circle. But that is the brute force mechanism. So let's work it out a smarter way. Let's get the data for first quadrant and then start using the symmetric property and make the rest of the quadrants as well. So let's get started and see how to get a particular point, okay, and how to understand that whether a point is lying on the circle, outside the circle, or how it's going to go about. So we know that you can clearly see that this is how I've represented the pixels. Okay, this is the one pixel, this is another pixel, this is the another pixel, right? Now, as the circle, the line of the circle is moving along, okay, it has to go through some of the pixels. Okay, it can't go through between the pixel, right? So only the pixel illumination will bring about the picturization of the circle. So which pixel to illuminate, okay, or which pixel is on in this case? Either this or this. So this particular line will have to grow through either this pixel or this pixel. So which one is closer? So we can directly say that the line or the circumference of the circle is closer to this particular pixel. So let's eliminate this. But this will be solving with the help of the midpoint algorithm. So let's see how it works. So now, if we put the value of x and y inside the equation of the circle, let it be any values of x and y, I'll be getting a certain value, right? Now, if the value comes out to be equal to 0, we can say that the point is lying on the circle. But if I put the x and y values and the value of the radius as well, and if I get value less than 0, then we can say that the point is lying inside the semicircle. And if it is greater than 0, then we can say that the point is lying outside the circle. So that's how we can go about. So in that case, that means we can take this particular midpoint, right? So now what would this midpoint be? Let it be xm comma ym. So what is xm comma ym? So we can say that it is uh, this point x-axis plus this axis divided by 2 and this y-axis plus this y-axis divided by 2. So we can easily get the midpoint, and then after getting the midpoint, if we place that into the equation, because we'll get some x and y values, and when we place it into the equation, then we get whether that particular point lies inside the circle or outside the circle or on the circle. As we get that, we can then decide if the midpoint is lying inside the circle, that means the line of the circle, right? The circumference of the circle is above the midpoint. So it clearly states that this particular line or the circumference of the circle is closer to the above pixel as the midpoint is lying inside. So we can say that the next point to be plotted, it would not be the below point, it would be the above one, that is xk plus 1 comma yk. So you can see the x is going to change for sure. It is going to change from xk to xk plus 1, and the yk is going to be the same if the midpoint lies inside. But what happens if the midpoint lies outside the circle? It means that if the midpoint lies outside the circle, then the circumference is closer to the below point. In that case, obviously the x value will change. X will be from xk to xk plus 1. But y, you can see it is going from the not choosing the above point but the below point, so it would be yk minus 1. So the below point will be chosen. Okay, so this is how the midpoint algorithm works. So let's understand how the derivation of it goes, and then we'll come back to the example. So this is the circle, right? And here we have the circle, and here we have the same diagram that we just went through. Now let's see the equation of the circle. So we just saw what is xm and ym. Xm and ym is what is it is this particular midpoint, right? Now what is xm and ym? Xm would be what? Xk plus 1 plus xk plus 1 divided by 2, which will be what? The same as xk plus 1. So you can see that we have these 2 points, okay, and it is xk plus 1 plus xk plus 1 divided by 2. Wherein what is yk? Yk is the above point, that is yk plus yk minus 1 divided by 2. So you can see it is 2yk minus 1 divided by 2. So if we simplify it, the midpoint would be what? Xk plus 1 comma yk minus half. Right? Now, we got xn comma ym. So let's place it into the equation of the circle. So we know what is the equation of the circle. It is x square plus y square minus r square. Right? And now we can say that when we place this particular values inside the equation of the circle, that works like the decision parameter. So let's call the decision parameter as P of k. Now, what is decision parameter? The value that we get through the decision parameter helps us decide which point to choose for the next particular pixel, right? The above one or the below one. So this tells us if the value is equivalent to 0, it is lying on the circle. If it is greater than 0, then it is outside the circle. If it is less than 0, then it is inside the circle. Depending on that, we choose which particular y next we need to choose. Okay, which is the next y pixel, the above one or the below one. Okay, so that is how we check. Now let's place in the value of xm and ym. So we have done this. Okay, now we say that the next decision parameter is dependent on the previous decision parameter. So it would be better if we have a difference between the both. So what we do is like we check out the next decision parameter, that is pk plus 1. So nothing we have done, we have just written k as k plus 1 in the below equation, right? And then we do pk minus p of k plus 1 minus pk. And when we do this, okay, you can see I have expanded, and slowly after expanding and changing the signs, you can see this minus converted to minus over here. This became plus, and we can clearly see this is plus r square minus r square. So we can directly eliminate them, right? And we can eliminate them, and we can see that I've over opened up these particular, it's like a plus b the whole square kind of thing that we have opened up. And so you can see it is xk square plus 4x k plus 4 plus this is yk plus 1 square minus yk plus 1 plus 1 by 4, because 1 by 2 will become 1 by 4 after squaring. And 2 times of yk plus 1 and half will become minus yk plus 1 only. And similarly, I've opened up these as well, opened up the signs as well for them. So that's why everything has turned minus. Okay, similarly, everything has been done. And you can see the final equation that we get is what? It is p of k plus 2xk plus 3 plus yk plus 1 the whole square minus yk square minus yk plus 1 plus yk. Rest of the terms gets eliminated. Okay, because it is plus minus, and that's how they get cancelled out. So this is the final equation that we are left with. Now let's proceed. So how to make a decision? Now, so to make a decision, we are going to be helped with the help of this equation, right? Now, so we know what is this equation pk plus 1, okay, that we have just derived before. Now let's see what happens if p of k is less than 0. If p of k is less than 0, that means point is lying inside the circle. That means my circumference is above that midpoint, so that means it is closer to the upper point. And what is the upper point? That is yk. So we can say that the y next, or yk plus 1, will be equal to yk, and you can see x is nothing but xk, it is x plus 1, right? So we'll just replace those particular details over here, and you can see as yk plus 1 is yk, we are replacing that in this equation. And so we can clearly see this yk plus 1 got converted to yk square, and this yk plus 1 got converted to yk, and obviously the signs are different, so they get deleted. So finally we have pk plus 1 equal to pk plus 2xk plus 3. Now, let's check the other scenario, wherein let's say that we are checking for pk which is greater than 0. That means the midpoint lies outside the circumference of the circle. That means the line is closer to the below point and not the upper point, right? So we can do that as well. So we can say that yk plus 1 is what? Yk minus 1. And what is x? X is x plus 1. So nothing changes much. So instead of yk plus 1, we are representing it by yk minus 1 the whole square, and even here yk minus 1. So let's open up the square, and when we open up the square, okay, finally after solving it, we get p next, that is pk plus 1 is equal to pk plus 2xk minus 2yk plus 5. So this is how we have got the decisions done. Now we can, but just before starting, we need to know the initial decision, that is p of 0. So how can we get p of 0? We can get p of 0 by placing x equal to 0 and yk equal to r. So this is wherein the first point that we are planning to plot for the octant one. So at this is the point that we are planning to plot, wherein x obviously will be equal to 0 and y will be equal to the radius. So this is what we are going to put up into the p of 0. And what is p of k? Okay, this is the equation for p of k. So now we are going to find out p of 0. So k is replaced by 0, and obviously x will be 0 and y will be equivalent to r. So that is what we see happening over here. It is 0 plus 1 the whole square plus r minus half the whole square minus r square. So when we solve it, it comes out to be p of 0 as 5 by 4 minus r. So if we want to take care, don't want a floating point working, then we can represent it by 1 minus r. So this is how we proceed, and this is how we get the first initial decision parameter. So let's proceed and let's check out how an example works. Um, so let's move on to the example. So here we are. Now we're going to look at the example, and we can see that we have the formulas over here already mentioned. So we are going to start with xk comma yk, wherein xk is 0 and y is the radius. Okay. So we are going to solve it for the first octant, that is octant 1. So we know what is the initial decision parameter, that is P0 is equal to 5 by 4 minus R, which can also be written as 1 minus R. Okay, it's just an approximation. Now, the third point, you can see that if the point lies inside the circle, like in this figure, you can see, right? So in this case, you can clearly see that we'll choose the upper point. So yk is the y next is not going to change. It's going to be yk, wherein x is obviously going to change from xk to xk plus 1, right? And we have the derivation of the next decision parameter to be calculating using the previous decision parameter. That's why we calculate the P0 to get started. Similarly, for the fourth point, you can see when if Pk is greater than 0, that means the point is lying outside the circle. So in that case, this line will be closer to this particular point. So you can see even the y needs to get changed. So y next would be what? Yk minus 1 because it is the below point. X would be what? Xk plus 1. And similarly, you can see that we have the derivation. So now let's proceed as we know all the formulas are ready. So yeah, let's get started. So we can say that let the radius be 10. So you can see that y is equivalent to the radius, so y is 10 and x is obviously 0. So let's calculate the initial P0. So what is P0? P0 is what we can say that is equivalent to 1 minus r. So directly it is 1 minus 10, that is minus 9. So we can write it over here as it is 1 minus 10, which is equivalent to minus 9. Now, so similarly, as we got the first P0, we can now proceed to check, okay, how to get the next decision parameter. So you can see if P0 is less than 0, right? So obviously it is minus 9, which is less than 0. So we'll be executing this third point. So in this case, we say that the midpoint is lying inside the circle. That means we are for the circumference of the circle, we'll be choosing the above point. So the y doesn't change, only the x changes. So you can see the x is changed from 0 to 1 and the y remains for the same, that is 10 to 10. And you can see that we find out pk plus 1, which is dependent on pk, that is minus 9 that we get from here, and it is 2 into xk. Obviously it is not new x, it is the old x. So old x was 0, so you can see it is 2 into 0 plus 3, right? So if we do that, we get minus 6. Now what is minus 6? It is again less than 0. So if it is less than 0, obviously we'll be executing the third point again. So in the third point, you can see xk plus 1 is obviously xk plus 1, right? X next is equal to xk plus 1. So you can see 1 is got converted into 2. And you can see y doesn't changes. So it is again 10. And then we find out the next pk plus 1. Okay, that is p next. That is what pk, which is minus 6 plus 2 into 1. So obviously this xk is the previous x and not the updated xk. So that is this particular one. So 2 into 1 plus 3, which gives you minus 1. So again, it is less than 0. So again, we see that the y doesn't changes, the x increments, and then you can clearly see again the p next, that is pk plus 1 would be what? Pk, which is minus 1 plus 2 into the previous x. That previous x is 2 plus 3, which is 6. So now it is greater than 0. If it is greater than 0, it means that my midpoint is lying outside the circumference of the circle. So the line, the circumference of the circle to be plotted, to be raster scanned, it will be choosing the below point. So when it chooses the below point, obviously the y will be decremented by 1. So you can clearly see as we got a positive value, the x got incremented as it is. You can see xk plus 1 is what? Xk plus 1. And wherein for y, you can see it as yk plus 1 is what? Yk minus 1. So this 10 changes into 9. Now, so how do you calculate pk plus 1 is? It is pk, that is 6. You can see that is 6 plus 2 into the previous x. So previous x was 3, so 2 into 3 minus 2 into the previous y. That was 10, so 2 into 10 plus 5. So if you do this, it is 6 plus 2, 3 are again 6, 12 minus 20, that is minus 8, minus 8 plus 5 is equal to minus 3. So you have minus 3 over here. So again, you can see it is less than 0. As it is less than 0, we know that the x increments, y doesn't. So it is x is incremented, and you see the 9 uh, value remains the same as 9, okay, for the y axis. So again, we got to use this pk plus 1 formula now. So this pk plus 1 is what? Minus 3. That is pk plus 2 into previous x, that is 2 into 4, plus 3, which gives us 8. So it's a positive value. It's a positive value. We have to increment both the sides. So obviously x gets incremented by plus 1, y gets decremented by minus 1. So you can see this 9 gets converted into 8. Now, so as it gets converted into 8, we calculate the next pk plus 1 with respect to the previous pk, and this is how we get the positive pk value. If we get the positive pk value, we increment x, we decrement y. So this is how we get 7 comma 7. Now, why do we stop at 7 comma 7? We can still keep going, right? But obviously we know that the circle, okay, it actually makes a 45-degree angle, right? It makes a 45-degree angle between two octants, octant 1 and octant 2. So it's just that we got to reach till here to know that this is the end of octant 1. That is a 45-degree angle. And at this particular point, obviously the x will be equal to y. So what is the stopping condition for octant 1? We could say that if it is x is equal to y, or if x turns greater than y, right? So if x turns greater than y, also we got to stop, because x turns greater than y, that means it would be a point in the quadrant 2, right? So that is how we work, and so we can stop over here. So now let's try plotting these points. So we can start with 0 comma 10, which is here, right? So 0 comma 10, then we have 1 comma 10, then we have 2 comma 10, then we have 3 comma 10, right? Then we have 4 comma 9, right? Then we have 5 comma 9, then we have 6 comma 8, then we have 7 comma 7, right? So you can clearly see the first quadrant is done. Now to get the second quadrant, we know that we just change the signs, right? So obviously this we have 0 comma 10, that will be converted into 10 comma 0. So you can plot it over here. Then you can see 1 comma 10 will be converted into 10 comma 1. Then you can say 2 comma 10, which is here, will be converted into 10 comma 2. Then the 3 comma 10 will be converted into 10 comma 3. Right. Then 4 comma 9 will be converted into 9 comma 4. Right. Then similarly 5 comma 9 will be converted into 9 comma 5. Right. Then you have 6 comma 8 will be converted into 8 comma 6. And finally 7 comma 7, which is the same. So you can see we have kind of plotted the first quadrant. We just got the values for the first octant, and finally we just using the symmetric property of octant 1 and octant 2, we did plot the second octant. So similarly, guys, we can go ahead and we can use the this particular first quadrant, we can just mirror it, or using the symmetric property we can get the below quadrant or the left quadrant, and that is how we can get the entire circle. Hope you have understood this particular topic, you have understood the formulas and the derivation. Thank you so much for attending this lecture. Kindly like, share, and subscribe. Thank you so much. Happy learning. Enjoy computer graphics. Thank you.